You are looking at the facilities of Sustainable Power Corporation in Baytown, Texas. This facility is the culmination of 21 years and $20 million of research and development by John H. Rivera, inventor of the Rivera process of biofuel production, considered by many to be the most advanced biofuel production process known. The equipment you see produces biofuel while at the same time reversing global warming and producing output products that can greatly enhance the agricultural outputs of land. You're looking at pelletized municipal solid waste, which enters the Rivera process equipment through this auger. The pellets enter the upper primary transition chamber, which is an airlock enabling the pellets to leave the room pressure atmosphere and enter a vacuum through an airlock in the secondary transition chamber below. As the pellets move through an auger now containing a vacuum, they enter the input end of the Rivera reactor tube, which you see here. This is an evacuated tube heated to 650 degrees, and at this point a catalyst produced by Mr. Rivera is placed into the tube, mixed with the pellets, which now begin to move by auger through the length of the reactor tube. The reactor tube is initially heated to 650 degrees by a number of electrical coils spaced approximately 1 foot apart along the 65-foot length of the tube. As the coils heat, the pellets begin to mix with the catalyst, and an accelerated reaction takes place where the molecules of the pellets are separated, become a gas at 750 degrees, and begin to disassociate as they further move along the tube at even higher temperatures. At this point in the tube, the reaction causes heat to be produced. The electrical coils are turned off. The reaction proceeds and begins to cool down to 600 degrees, whereby the gaseous form of the pellets now recondenses. The condensing gases are cleaned by cyclonic cleaners, first the primary cleaner and then a secondary cleaner, which remove varying particles of dust from the gas, and which also begin a process in the condensation tank, which you see in the back, that begins to produce bio oils in addition to the gases we've already cleaned. The byproducts cleaned out of the gases exit the equipment through these chambers and airlocks, similar to the input airlocks you saw previously. The main contents of the tube leave through a major airlock into an auger at the base of the facility, which then leads from the facility through the wall into the outside processing yard. As the reactants continue to move through the auger, they cool down, enter a secondary auger where biofuels are continued to be removed, and where biochar is now discharged into a holding tank, as you can see here. Other processes remove the gases from the system, compress them, recondense them, store them either as liquids or in gaseous form in appropriate tanks. And the fuels are then used to power a generator which drives the entire process, while any excess gases, usually hydrogen or methane, pass through a venting system and are burned off in a very clean form that produces absolutely no emissions or pollution. This stack is now venting and burning the hydrogen gas, which you can see produces absolutely no pollutants. A secondary result of the process is the production of biochar, a revolutionary material which can enhance agricultural lands, convert barren lands into fertile lands, provide nutrients to crops, and remove carbon dioxide gases from the atmosphere, thus reversing global warming.